In this video, we are going to look at examples of complex numbers, everything from simplifying to using operations with complex terms. Now, the first thing to note is that the single most important idea when surrounding your complex numbers is the idea that the I represents a negative under the radical. That being said, if we square the imaginary, we end up with -1. This rule here is something that has to be applied every time you try and approach a radical that is even, that has a negative underneath it. So here we've got a couple examples where we're going to look at how to go about simplifying these radicals without a calculator. Okay, in other words, we want the results to be given in exact form, not to be given in any sort of decimal form. So here we are actually looking for the exact radical form of these examples. So the first one is we want to take the square root of -9. Now obviously the negative under the radical cannot happen. So what we want to do is we want to take that negative and we want to pull it out as the imaginary, thus turning our problem into the square root of 9i. Now we know the square root of 9 is going to come out to being 3, so in this case this would simplify down to being 3i. Okay, pretty simple. This next one's going to be a little bit more in depth because we have more than just a single value underneath it, but again it's negative. So your first step has to always be to take that negative out as an I. So when I do that, I like to actually show by pulling it out. What that does is it means that I'm not going to forget it as I work my problem. So here this is going to change. We're going to put the I out in front for now. And we've got the square root of 24, x to the 5th, y to the 12th. So we have to reduce this down all the way, and you want to use any reduction tools that you have to be able to reduce your radical. So we have 3 pieces that have to reduce: the 24, the x to the 5th, and y to the 12th. So we can start with the square root of 24. We want to break it down. So if we break this down, we know 24 can become 6 times 4, where 4 can become 2 times 2. We have a single group here, so this is going to pull out and leave the 6 behind. Then we have to look at the square root of x to the 5th. So again, x to the 5th does not divide evenly, so here we would pull out an x and leave x to the 4th. If we look at x to the 4th, we know this can break down into being x squared and x squared. Again, here's our group. So the x squared pulls out and an x stays behind. Last, we have the square root of y to the 12th. Now, so far both of these examples I broke them down, but I'm going to show you another trick here with this one that we can use. My index for the square root is 2. And so essentially what we want to do is we want to look at this in terms of your power divided by your index, and we want to know if that's even. So in this case I would have 12 divided by 2, which equals 6. So when we're looking at that, what we would pull out, so here we would pull out y to the 6th power. Okay. So that being said, we can put it all together, and what we're left with is we are left with 2x squared y to the 6th I square root of 6x. Okay. And this would be the simplified complex result that we were looking for. Now the last one that I wanted to look at was this one. So the square root of 15, we would take this and we would pull again out the I, leaving us with I square roots of 15. Now the square root of 15 does not reduce any, so this would stay exactly as is. Now that being said, we do have what's called standard form. And standard form is the form a plus bi, where a stands for the real, b is your imaginary coefficient, and I stands for the negative under the radical. So with standard form, there's one big thing you must always remember, which is you always write solutions in standard form. So you need to be very careful with that everything you do in the complex world, you always revert back to standard form. And that is going to be most important as we get into these next examples, which has to do with operations using complex terms. So we're going to start with adding and subtracting. So what we have here, as you can see, we have the standard form of two different forms that we want to combine together. So we would combine this the same way we combine variables. You're going to combine reals to real and imaginary to imaginary. So we can go ahead and rewrite this. Now that being said, you want to take your power or your sign out in front of your second term, and you want to distribute that sign through the term. Now since this is positive because we're adding, it means that my signs or nothing is going to change or be affected there. So in this case, I can group my reals, so negative 12 plus 5, and I can group the imaginaries, negative 4i plus 3i. Now we have two groups or two problems here. We've got the real part and we've got the imaginary part. The real part we would combine, negative 12 plus 5 gives us negative 7. Negative 4i plus 3i gives you minus I. Now we're in standard form, a plus bi, so we're good to go. Alright, let's look at the next one. Notice here I've got radicals. Whenever you have radicals, the first thing that you have to do is you have to convert to I form. Okay? So here we're going to take this square root of 36. We're going to pull that negative out as an I. And we know that 36 changes, and this is going to become 7 minus 6i. We have a negative between, and we now need to look at this back one. So the negative here we're going to pull out again as an I, and here we're going to end up with 2 plus 3i. Once you convert to I form, you can go ahead and work on combining. Now just like before, we need to take the operation in front of the second term, and we need to distribute it through that second term. So this becomes 7 minus 6i minus 2 minus 3i. Now with that we can rearrange 7 minus 2 minus 6i minus 3i. That puts us into our reals and our imaginaries. So here we're going to end up with 5 minus 9i. Again, we're in standard form, so we are totally good to go. Now if you think about your order of operations, the next one that the next big one that we have is we have multiplication. And so in this case, in order to multiply, we're going to use the idea of the FOIL method. Okay? So first, outer, inner, last. So with this, we're going to go ahead and start multiplying. So we have first terms, so we're going to have 8 and the negative 2. So we're going to have 8 times negative 2. We're going to add it to your outermost terms. So your outermost terms are going to be the 8 and the 5i. So this is 8 times 5i. We have to add this to the inner terms. So these are my inner terms here. So negative 3i times negative 2, and we have to add it to my last terms. So here we're going to have negative 3i and a 5i. Now if you look close enough at what I drew here, you can see that I drew a little smiling monkey face. Of course, if you can't see it, that's okay, I am a nerd, but here you go, smiley face, and that's how you know we did it right. Now I also grouped them as individual pieces instead of trying to do it all in my head, which is something I highly recommend, especially if you're not very confident with math, or if you are finding that you're needing a little bit of an extra help. This is a step that you can use. Now once you've got everything separated, you just have to start simplifying. So 8 times negative 2 is a negative 16. We're going to add this. 8 times 5 is a 40, and you bring the I along like it's a variable. Negative and negative is positive, so this becomes plus 6i. And then I have positive, negative, positive, so this is going to be minus 3 times 5 is 15, I squared. I times I squared. Now, we need to combine this middle term. So we have negative 16 plus 46i minus 15i squared. Now one of the things we have to remember is we've got this I squared here. And the rule that we have says that I squared equals negative 1. So we need to rewrite that. So this is a negative 16 plus 46i minus 15 times a negative 1. This becomes a positive, so we end up with negative 16 plus 15 plus a 46i. We now have our real that we can combine. This becomes negative 1 plus 46i. We're in standard form, so that's how we know that we are done. Okay, last but not least, we have dividing. Now, the biggest thing that we have to remember about dividing is this very first sentence. And that sentence says, you cannot leave i's in the denominator. Because of that, you're going to use what's called the conjugate. In this case, it's a complex conjugate because we have an I in our term. The complex conjugate means the opposite operation of the denominator. Okay, so we're looking for your opposite operation of the denominator. So in this case, my denominator is 7 plus 2i. So here, my complex conjugate will be negative 7 minus a 2i. So what we're going to do is we're going to multiply this fraction here, this rational, by the complex conjugate both on the top and the bottom. So we're going to turn our problem into 5 minus I over negative 7 plus 2i multiplied negative 7 minus 2i over negative 7 minus 2i. Now, when looking at this, we're going to be foiling across the top and foiling across the bottom. So what I like to do is I like to go ahead and just give myself a big dividing line, and I like to work on the bottom first. The whole point of multiplying by this complex conjugate is to make the I term disappear. So as long as that I term goes away, chances are I've done it correctly. So again, we're going to start putting it together. I have negative 7 times negative 7. Add it to my outer terms. Negative 7 times negative 2i. Add it to my inner terms. 2i times a negative 7. And add it to my last terms, a 2i times a negative 2i. Now, if we take a look at this, I can go ahead and reduce. So I'm going to go ahead and draw myself another division line. Negative and negative is positive. 7 and 7 is 49. Negative and negative is positive, so this becomes plus 14i minus 14i minus 2i squared. Now if you take a close look right here at this middle term, notice it's going to completely cancel. 14i minus 14i means this piece goes away, and we have an I squared. So my rule again is that I squared equals negative 1. So this I squared goes away. Therefore all the i's are gone, which means I did it correctly. Knowing that I did it correctly is going to allow me to multiply across the top and start simplifying. So we're going to FOIL across the top here, just like we did the bottom. So we have 5 times negative 7. We're going to add this to my outer terms. 5 times a negative 2i. Add it to the inner terms, negative I times negative 7. And add it to the last, negative I times a negative 2i. When we start simplifying this down, we get a negative 35 minus 10i plus 7i plus 2i squared. And again, just like before, here's that I squared, which follows our rule, which says it's negative 1. So in this case, if we go ahead and look at it again, I have negative 35 minus a 3i plus 2 times a negative 1. And then I have a 49 minus 2 times a negative 1. When I simplify this again, I have a negative 35 minus 2 minus a 3i. And on the bottom I have 49 plus 2 I'm sorry, this is a 4. 2 times 2. That's a 4, which makes this right here a 4. I do apologize. Which will make this a 53 on the bottom. So the last thing that we have is to combine. So this becomes negative 37. Remember, we need standard form, so we're going to break up our fraction to say over 53. And then we're going to have minus, and it's 3 over 53i. Okay. So there we have it. We have our 4 operations: addition, subtraction, multiply, division, as well as our rules that we use when we try to simplify. So if you have any questions about any of this, please let me know. Otherwise, I do hope you enjoyed this video. I hope that my mistakes showed that not everybody is perfect, and I look forward to talking with you next time.